Here, I'll split it over today and tomorrow, instead of just doing it all one day. The paper I just gave you, you'll need that again tomorrow. All right, I'm gonna do that over 2 days. Now, here's, all right, everyone get connected here. Now, this is all your book. Turn to page 668 first. $668. You don't have to write this down. Look what this says up here. We already did this, but I got news for you. Some of you messed this up badly on that quiz earlier this week. These were the ones where you had to get a common base on each side and then equate the exponents to get your answers. I'll give you those papers back later. This ain't going away for what's coming up later this week. Okay, turn to page 676 in your book. Move ahead. 676. Okay, that's okay. These were the ones where you had to first convert it to exponential form and then solve. All right? Now, you see all that up there? That's that quiz you took earlier this week. 20-point quiz. The first 10 problems were those kind. The second 10 problems were those kind. Again, it's not going away for what's coming up later. Now, here's, take your notebook out. Okay, now you're going to have to write this down. I'll show you what's going on. Here, do this first. In your notebook, today's March 29th, I think? Yeah. Wednesday, March 29th. Put this A and B problem next to each other in your notebook right now. A and B. Put them next to each other. Now, come on now, listen to what I'm going to ask you. Be smart here. Honors class. Now, I'm going to try to screw you up here. Okay? Don't let me. I'm going to try, though. These are both exponential equations, right? Like 1 to 10 on the quiz you took the other day. If I said to you, put these next to each other in your notebook. If I said to you, I want you to get a common base on each side, I want to hear your response. If I said to you, I want you to solve these exponential equations, I want you to get a common base on each side and equate the exponents, what would you say? Be smart, fellas. Look what's up there. Keep in mind, I'm trying to screw you up. Don't let me. You can't. You understand? How in the hell are you going to get a common base with what you see up there? There ain't no way. There ain't no way you're going to get this 3 to raise to some power. You're not going to get that 10 raised to some power. So that means we got to do something else. So in your notebook, this is the general method for solving an exponential equation. We can't do it by getting a common base. If we could, we'd do it and we'd go right to the answer. Okay, now you need to write this down. There you go. Now, You see where this says or the special property? Don't, here, let me just do this. Don't write that down. We'll just, boom, end it right there. Go ahead, you gotta mark this down. This is the general method for solving an exponential equation. Now, you're gonna need your calculators out. These ain't gonna come out perfect. Take logarithms to the same base on both sides of the equation, and then use the power rule of logarithms. Now, guys, when I say the power rule, remember the homework assignment I just gave you back the other day? It was 2 assignments, the ones you did in class last week with all the properties. Remember the log of a product was the sum, the log of a quotient was the difference, and when you had an exponent, remember it went out in front times the log. That's what I mean by the power rule. Okay, now go to your notebook, watch this. These kind of ain't too bad. I can't get a common base, so I have to use the general method for solving exponential equations, which says take logarithms to the same base on both sides. Now, what's a common logarithm? I just gave you this the other day. What's a common logarithm? I just did this yesterday. This is where some of you don't do well. Yesterday I did common logarithms, natural logarithms. What's a common logarithm? It only means one simple thing. David? Base 10. And you don't even have to show the 10, right? Because it's understood. So, we're going to take the common logarithm on both sides. Now, in your notebook, log of 3 to the x equals the log of 12. You do what I'm doing here. Over here, the log of 10 to the x equals the log of 4. Take the log on both sides. Now, look what it says up here. Take logarithms on both sides and then use the power rule. The log of 3 to the x means what using your properties? We already did properties. You can't forget this stuff. Where does that exponent go? Already did this. Ethan. So this is x log of 3 equals the log of 12. Stay with me here. And this one is x times the log of 10 equals the log of 4. Now, your homework, these 5 to 10 here that are on page 703 is going to be these kind of problems. In fact, go to page 703. Your iPad's already in your textbook. Go to page 703. Go there so you see this. Go to page 703. Look at the bottom of page 703. Just glance at 5 to 10. Are they all similar to the 2 that are up here? Yes. Really? All right. I'll get that scanned to you when I'm done here then. All right. They're like this, though. Now, the directions are going to say solve each equation. So we're going to solve for x. Give solutions to 3 decimal places. Give solutions, this is what it's going to say in your book, to 3 decimal places. Fellas, look, don't let the logarithms bother you. If you had 3x equals 9, you would divide both sides by 3 and x would be 3. Okay, so there's logarithms here. What would you do to both sides here? You get x by itself. You're just solving for x just like you would in any normal equation. Somebody, what would I have to do to both sides to get the x by itself? This is not a hard question. Do what you always do when you solve equations. So,
divide log of 3.
That's right. Divide both sides by log of 3. So look, here's what you write down. X equals log of 12 divided by the log of 3. Come on, I need, hold on one second. I need somebody to be really smart here. It's information that's already been given to you. You just don't know when the things I've already given you are going to pop up. What is the common log of 10? Good. See a lot of people putting their hands up. Harris,
1.
do you understand that? Wasn't that one of the properties I gave you? I mean, that's 10, right? Log of 10 to the base 10. Now, just so you can see it, I'm just going to put that there. So x times 1, this is just x. Okay, now, with your calculator, everybody, you got to make sure you're entering things correctly. It says give the answers to 3 decimal places. So in your calculator, you're just going to punch all this in. You're going to go the log of 12 divided by the log of 3. Now when you figure out the log of 12 and then you go divided by the log of 3, you're going to have to hit your equal button or your enter button. I need you all to do that on your calculator. And then I need someone to give me what the answer is to 3 decimal places. Everybody should have the exact same answer. Just your calculator's going to do all this for you. Max.
2.262.
Does anyone have a question on that one? Yes.
Would it be the same if you put the log of 12 divided by 3, or does that have to be like a separate, does that have to be like a log of 12 divided by log of 3?
Yes. And I'm glad you asked that question because I'm going to show you something right now. I can find it. You can't do what you said. It does not mean the same thing. It has to be separate logarithms. You can't say, and you can't do this either. You can't say the log of 12 divided by the log of 3 is the log of 4. And say 3 goes into there, 4. You can't do that. That's absolutely a no-no. They're separate logarithms. So no, you can't do what you said. Yes?
Since their exponents can have a common base, why would we like subtract them?
We're just entering it right into the calculator. Look, this right here, doesn't that just represent some number, which is your answer? And the directions are going to say, give each answer to 3 decimal places. So once you get to here, and all you just have is logs of numbers, calculator takes over. You don't have to do anything further. Just punch it all in your calculator. Now, this one came out easy. Oh yeah, what's the answer, somebody? Now it's coming out right away because this turned out to be a 1. So I didn't have to even divide there. What is it? Howard?
0.6021.
3 places. The directions are going to say 3 places. Okay, now, go to the handout I just gave you, everybody. Go to the handout. And you're going to write on the handout. We're not covering this whole thing today. Don't lose this paper. Example 1. Here it is right here. It's on your paper. Common base? No way. Impossible. So what did I say you do first? We're using the general method for solving an exponential equation. Come on, what's the first step? I already did 2 problems for you, so what's the first thing you do, Ethan?
Change the log of 2 to the x minus 1.
On both sides.
Yeah.
So go ahead, on the handout. The log of 2 to the x minus 1 equals the log of 15. Now pay attention, there's going to be something a little different about this one. Now what? Come on. Now what? No.
Move the x minus 1 in front of the log.
Now, you know what's different about this one? The exponent has 2 terms. Over there, the exponent is just one thing. So when you move this out in front, what do you think you have to do with that x minus 1? You have to. You have to write it a certain way. because there's two things there, I'm gonna have to, Chris, group it. So this is x minus 1 times the log of 2 equals the log of 15. Now, make sure you're writing this on your paper there. All right, I'm not gonna say anything here. I need you guys to be smart. What are the directions here? Solve for x. It's an equation. Solve for x. What do you suppose I'm gonna have to do next here? What do you suppose? Guys, freshman algebra. Hate to keep bringing it up, but when you solve linear equations in freshman algebra, if you had any grouping symbols in the problem, what did you do first? That's a pretty simple question. When you solved equations in freshman algebra, if there were grouping symbols in the equation, what did you do first? My God, I can't believe every hand is enough. Oh my gosh. I'm just making this up. There. Are you kidding me? That's baby stuff. I just made that up. If you solved an equation like that in freshman algebra and there were grouping symbols in the equation, what did you do? My God. Really? Somebody, please, what did you do when you saw grouping symbols in the equation? Joe? Okay, forget it.
Wait, crap, I lost it.
Hope you find it. Max,
You dealt with it in the grouping.
how did you deal with it? Thank you. You had to get rid of them, right? You distributed. My God. Look over here. See this log of 2? What is that? It's a number. Doesn't it represent a number? If you had, look, let's say that was a 3. Now, you don't normally see it after, but it means the same thing. Wouldn't that be 3x minus 3? Okay. Here's a quantity times the log of 2. Can somebody distribute and tell me what to write down? You're going to take the log of 2 times x. You're going to take the log of 2 times minus 1. Why is this so hard? Distributive property. What's the log of 2 times x? How do you think I want you to write that? I was not anticipating this, you guys. I wasn't anticipating this was going to be that hard. What's the log of 2 times x? How do you think I want you to write that? Howard?
X log 2.
That's right. X log of 2. What's the log of 2 times minus 1? Are you following me now? Go ahead.
Negative log 2.
Minus log of 2, make sure you're getting this, equals the log of 15. Do you see all I did there as I distributed? We're solving for x just like a normal equation in freshman algebra. Don't let the logarithms bother you. Now, what do you think you're going to do with this minus log of 2? Somebody? You're solving it just like a normal equation from freshman algebra. Why are you doing this? I mean, I can't believe the hesitation. You're letting them LOGs bother you. Don't let them bother you. They're just numbers, like any other number. No, they don't. No, they don't. And here's why they don't. This don't have any x with it. This does. That means they're not similar. You can't do that, Alex.
Would you put the log of 2 to the other side?
Yes. Variables left, constants right, right? I'm not going to move that. That has a variable. So I'm going to bring down x log of 2 equals log of 15. Okay, now I'm just putting that over there. So tell me how to write it. I'm just putting it on the other side. Man alive, guys, it's a regular linear equation. Rob, plus log of 2. Who has a question? You sure? Okay, I want to solve for x. So what do I have to do to both sides? You got one more step. I got x log of 2. So what am I going to do? I want just x. So what am I going to do? Ethan,
I was about to log 2.
Okay, now make sure you're putting this on the paper. So it's all of this, log of 15, plus the log of 2, divided by the log of 2. Oh man, now hold on here. I'm really gonna try to screw somebody up. Please don't let me do this, because this would be horrible. Maybe some of you know where I'm going with this. What can I do to the right-hand side? I'm getting ready. Because if there's a certain thing I hear, I'm going to beat the hell out of somebody. Look at that. Look at that. Can you do anything to the right-hand side to reduce? This would be really good. Go ahead, Joe. You better start running if you say a certain thing.
The log of 2's could be canceled.
Come up here. Come up here! Close that front door. Virgod's close back. Let's get this the hell out of the way here so I can swing hard. What the?
How can they? Oh,
What do you mean, oh?
they're like this imaginary.
Spit it out!
There's imaginary grouping there, so those can't cancel.
Imaginary grouping?
Like that's
What
kinda,
the hell does
like-
that mean?
that's kinda like-
Imaginary grouping!
It's a quantity or whatever. Something like that. Those can't
Pick
cancel.
that up for me, please. Get over here. The problem's over here. It ain't over there.
Okay, those can't cancel.
Why?
Cause
You damn right they can't cancel. It's one of the worst mistakes in algebra you could possibly make.
Because there's a plus sign connecting those two together.
Because what do you never cancel in a million frickin' years?
Is it called a quantity?
Yeah, it's an imaginary quantity. What are you smoking?
No. I don't know what it's
There's
called.
no way. That's what I didn't want to hear.
Yeah, I didn't
You
realize
can't
that.
cancel those out. Go sit down before I beat your ass. Go sit down. You can't do that. Now, on your calculator, get the answer. You're done with the work. Enter log of 15 plus the log of 2, then hit the equal sign, divided by the log of 2, and then hit the equal sign. Your calculator's going to do it all. Shut up back there. Don't talk to him.
We did the same thing.
Joe, your notebook, handout, and calculator. Pick it all up. Come up here. Go sit next to
Alright.
Go ahead.
Can I bring my pencil?
Yeah. And your iPad.
Oh.
Trade with Dowds right now. Okay? Dowds, go to back. Wow. Talking about up close and personal. Now. Wow. Now, you gonna talk to your invisible buddy now?
No.
Dumas is hurt. He's on crutches. He's down in Ian's room, milking his leg or whatever. Okay?
Yeah. Having him.
Why did you do that?
Do what?
Oh, you getting all the surgery, I forgot that this thing. Has that been on the whole time? Ooh. Ooh, kind of forgot about that. All I said was ass. That was no big deal. Right?
Right.
Okay. All right, what is this? We're almost done. Ian will get a charge out of this, I'm sure. Should be laughing his butt off. What's the answer? 3-digit decimal. What is it? Bloomstein?
4.907.
4.907. Okay, now, I'm almost finished here. Look on your hand. Does anyone have a question here? You see these 3 examples? That's what 5 to 10 is gonna be. It's gonna be just like it. All right, now go to example 3 and 4. And you're writing on the paper again. Are those exponential equations? Sure they are. But, what do you see in these exponential equations? When you take the log on both sides, what kind of a log you going to take? Now, come on, this is where you got to be smart. You're still going to take a logarithm on both sides, but what kind of logarithm are you going to take because of what you see? And you just learned this yesterday.
Natural.
ln. You're going to take the log on both sides again, but it's going to be the natural log. So go ahead, you're writing on the paper. Natural log of e to the negative 0.01 times x equals natural log of 0.38. All right, come on, tell me what the, Ethan, do you have a question?
Yeah, so we only use the natural one when there's an E. In
Correct. Good question. When it's an exponential equation, when you see that e in there, then it's natural log on both sides. Now, do you remember from yesterday? Can somebody tell me approximately what that e equaled? What was the decimal number for it? Should be in your notebook. Remember yesterday when I was doing this in your calculators? What's the approximation for e? We did it yesterday. What's the decimal approximation for this e, Rob?
2.718.
All right, that's enough. We'll just say it was about 2.71. Okay, what's the next thing you do? What do you do with those exponents? You finish the same way. It's just a natural logarithm. The procedure is the same. What are you going to do with the exponents? Just like I did in all three of these. Come on. What are you going to do with the exponents? Power rule. Andrew.
I think the 0.003x.
0.003x times the natural log of e equals the natural log of 40. Over here, negative 0.01x times the natural log of e equals the natural log of 0.38. Fellas, come on now. These are almost done. And you got to be smart here again. Come on, you got to be smart here. Somebody please raise your hand and tell me what's going on in those two places I circled. Oh, come on. It's not that hard either. What's the natural log of e? You know what the base is. You're not going to see it written. Right? Chris?
1.
1. Just like this. Log of 10. Base 10 was 1. Natural log of e. Do you understand? Those are just 1s. So if that's a 1, this is just this. If that's a 1, this is just this. What's the only thing left to do in both of these? And then your calculator will take over. Solve for x. What are you going to do to both sides here? You're solving it just like a normal equation now. Howard?
Divided by 0.003.
This is the natural log of 40 divided by 0.003. This is going to be the natural log of 0.38 divided by negative 0.01. Now let's see, were you paying attention yesterday? You see that numerator? What kind of an answer will the natural log of 0.38 be? Covered this yesterday. You guys got to look at this stuff from day to day. Some of you never look at this stuff from day to day. Ethan.
It'd be negative.
It's going to be negative, isn't it? Because it's between 0 and 1. So go ahead. Go ahead. Take the natural log of 40 and divide it by 0.003. What is it? Three decimal places. What is it? What is it? David. 1,229 point, what'd you say?
626.
And Now remember, that numerator is gonna be negative. So a negative divided by a negative is gonna be a positive answer. What's the other one? Natural log of 0.38 divided by negative 0.01. Your calculator's gonna do all the work for you. Nick, you got it?
Yeah, what's that?
Go ahead. Tell me what you got. 3 decimal places.
96.758.
Okay. Now, here, answer. It's page 704 there.